Hello, my name is Professor Alan Hoffman. I'm in the Mechanical Engineering Department at Worcester Polytechnic Institute in Worcester, Massachusetts. This video is associated with static systems, commonly called statics. Statics is the study of forces and moments acting on bodies which are in equilibrium. Therefore, we have to understand the definition of equilibrium. In equilibrium, the sum of the forces in any direction must be zero. And similarly, the sum of the moments about any axis must also be zero. The material covered in a statics course is fundamental to the successful completion of more advanced engineering courses. In particular, stress analysis in higher level courses, as well as dynamics in higher level courses, and also all design courses. Another definition of statics is that it is a study of bodies and systems that are not accelerating. Thus, the linear accelerations in all directions are equal to zero, and also the angular accelerations about any axis are also equal to zero. Statics has many common applications. Bridges are in static equilibrium. Buildings are in static equilibrium. The chair and the table I'm using to produce this video, each of these bodies is in static equilibrium. Newton's laws state that the sum of the forces equals the mass times the acceleration. These are vector equations, so they apply in all three directions. Similarly, the sum of the moments about any axis is in a slightly simplified form equal to the moment of inertia of the body times the angular acceleration. Both forces and moments are vectors, and linear accelerations and angular accelerations are also vectors. In statics, both of these accelerations are equal to zero. In two dimensions, which will be the primary subject of this video, one way of writing the three equilibrium equations is to state that the sum of the forces in the x direction, you must first define a coordinate system before you can apply the equations of equilibrium. So the sum of the forces in the x direction are equal to zero. The sum of the forces acting on a body in the y direction are equal to zero. And the sum of the moments about the z-axis is also equal to zero. Now these equations can also be arranged in a slightly different manner. As I described them, there were two force equilibrium equations and one moment equilibrium equation. However, you can also solve a two-dimensional equilibrium problem by using two moment equations and one force balance equation. The requirement, however, is there are only three equations, and thus on any free body diagram, and we'll define that next, there can be at most three unknowns if you're going to solve for the forces on that body. In three-dimensional equilibrium, there are 6 equilibrium equations. But that would be the subject for another video. A free body diagram. The crucial ability in both statics and also dynamics and essentially all the succeeding courses like stress analysis and in design is to be able to draw free body diagrams. Free body diagrams isolate a body from its surroundings and show the effects of these contacting bodies as forces and moments acting on the body you have isolated. Most forces act directly through surface contact. However, such forces as gravity, which is represented by weight, acts through a distance without direct surface contact. Thank you very much.